Hello students, welcome to KLS Gokte PU College of Commerce and Science, Belgavi. This is our fourth lecture on a topic structure of atom. This is Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. Let us see the contents of today's topic. The first one, atomic models. So there are several models we have learned in 8th and 9th and 10th standard. So out of those models, we are going to discuss only the Rutherford's gold leaf experiment. The second one will also try to understand drawbacks and its observation of Rutherford's model. And lastly, we'll try to understand the electromagnetic radiation. So we'll try to finish these 3 points in today's class. Okay. So Rutherford gold leaf experiment, or it is also called as the Rutherford's gold foil nuclear model. Before we discuss this model, you should know the J.J. Thomson plum pudding model. Yes, do you remember? Because you have learned in ninth standard, I guess. So what was the J.J. Thomson's plum pudding model? He said that the positive charge is present everywhere in an atom, and in between this positive charge, the electrons are present. Okay, so it concludes what? No space is present in an atom, and electrons are present everywhere, and positive charge are present everywhere. Okay, so he said that electrons are positive charge is nothing but protons are present in an atom, and he got the Nobel Prize for this invention. Okay, but when the Rutherford carried out the gold leaf experiment, then the plum pudding model got failed. Why he got failed? Let us discuss now. First of all, to carry out the Rutherford gold leaf experiment, we should have the gold thin foil, also the fluorescent screen or zinc sulfide screen. We should have the lead container, and in that lead container we should have the radium which should emit the alpha particle. So this is the setup, and behind this also we are having the fluorescent screen. Okay, now first the radium is emitting the alpha particles. So let us know about the alpha particles. The alpha particles are positively charged particles. Fine. Okay, alpha particles are positively charged particles. So when the stream of alpha particles are passed through this gold foil, so maximum rays are coming out of these alpha particles. Okay, maximum rays are coming through this gold thin foil. हमको कैसे पता चला कि maximum rays are coming out of the gold thin foil? Because of this fluorescent screen. So when the alpha particles are coming out of the thin gold foil and when it is stuck to this fluorescent screen, then it glows. Actually it glows, and it is understood that maximum rays are coming out of the gold thin foil. Fine, समझ में आ रहा है? So when the alpha particles stuck to this zinc sulfide screen, the zinc sulfide screen started to glow, and it indicates that the particles are striking, or particles are passed through the thin gold foil and it strike to the zinc sulfide screen. So the use of the zinc sulfide screen to know whether the alpha particles pass through the gold thin foil or not. Fine. Next one, you can observe here. Here also some alpha particles are passing through the thin gold foil, but by a small angle. And here also, out of many alpha particles, only 2 alpha particles are deflected back by a large angle. Okay, ये कैसे पता चला? We are here also we are having the zinc sulfide screen or fluorescent screen. ओके, सो ये एक ही बार एक्सपेरिमेंट नहीं किया गया, बार बार इस एक्सपेरिमेंट को रिपीट करने के बाद हमको समझ में आया कि अल्फा पार्टिकल्स आर पासिंग थ्रू द गोल्ड फॉइल by small angle and by a large angle. Fine. So this is a experiment of Rutherford gold thin leaf. Okay, so समझ में आया क्या है एक्सपेरिमेंट? When the alpha particles are stuck to the thin gold foil, maximum alpha particles are passing through the thin gold foil, and few are deflected by a small angle and few are deflected by a large angle. फिर ऐसा क्यों होता है? Okay, why it happens? So let us try to understand. Okay, so the result of these experiments were unexpected. We'll explain point by point. The first point is what? The most of the alpha particles are passed through the gold foil undeflected. As I said that most of the alpha particles are passed through the foil undeflected. Second is what? A small fraction of alpha particles were deflected by small angle. ये पॉइंट भी मैंने बताया, वेरी स्मॉल एंगल से कुछ ही पार्टिकल डिफ्लेक्ट होते हैं. एंड थर्ड वन, वेरी फ्यू पार्टिकल्स, वन इन अ 20,000, वन पार्टिकल्स आउट ऑफ 20,000 वेर बाउंस बैक, दैट इज वेर डिफ्लेक्टेड बाय नियरली 180 डिग्री. सो मैंने ये भी कहा था कुछ ही पार्टिकल्स है. ओके, 1 और 2 आउट ऑफ 20,000 डिफ्लेक्ट कितने एंगल से होते हैं? 180, बाउंस बैक. ओके, जैसे हम कैरम में रिबॉन्ड करते थे, रिबॉन्ड शॉर्ट रहता है वैसे. Okay, so these are the results of this experiment. What observation we can make on this result? The first one, most of the space in the atom is empty. Okay, most of the space in the atom is empty as most of the alpha particles are passed through the foil undeflected. जैसे कि हमने कहा most of the alpha particles are passed through the gold foil. So gold foil is also made up of atom, right? So gold foil भी किससे बना है? एटम से बना है. So most of the alpha particles are passing through the gold foil means what? एटम में empty space है. ओके, एटम में क्या है? empty space है, बिकॉज गोल्ड फॉइल उसमें से जा रहे हैं. सो गोल्ड फॉइल से अल्फा पार्टिकल जा रहे हैं. इट इज़ नथिंग बट व्हाट? द अल्फा पार्टिकल्स आर पासिंग थ्रू द एटम. सो इससे हमको ये पता चला कि एटम में empty space प्रेजेंट है. फाइन. ओके, the second, a few positively charged particles were deflected. So few positively charged particles are deflected. ऐसे कुछ particles क्या होते हैं? डिफ्लेक्ट होते हैं. So ये क्यों होता है? So something is there in an atom, okay, and that should be a positively charged. Why positively charged? Because these rays are positively charged, and these rays will change their direction only when the positive charge is present ahead. Okay, suppose if positive charge is present there, so small volume of positive charge should be there, and due to that reason only few alpha particles are what? Deflected. Okay, next, the deflection must be due to enormous repulsive force showing the positive charge in the atom. So deflection किससे हो रहा है? Because small volume of कुछ तो present है atom में, and that should be a positive. Okay, small volume और स्मॉल रीजन का कुछ तो प्रेजेंट है एटम में, और उसका चार्ज क्या है? पॉजिटिव है. उसी वजह से इस अल्फा पार्टिकल जो पॉजिटिव चार्ज है वो क्या हो रहे? डिफ्लेक्ट हो रहे. इस एक्सपेरिमेंट से पता चला. अब बाद में द पॉजिटिव चार्ज हैज़ टू बिकम कॉन्सेंट्रेटेड वेरी स्मॉल वॉल्यूम दैट रिपल एंड द अनडिफ्लेक्टेड. सो बाद में हमको ये भी पता चला जो अल्फा पार्टिकल डायरेक्टली स्मॉल रीजन और पॉजिटिव चार्ज को स्ट्राइक कर रहे हो, वो क्या कर रहे हैं? बाउंस बैक कर रहे हैं. सो वेरी फ्यू अल्फा पार्टिकल, हमने कहा था वेरी फ्यू अल्फा पार्टिकल्स आउट ऑफ 20,000, 1 or 2 अल्फा पार्टिकल्स आर बाउंस बैक. इट मीन्स दैट a very small volume of positive charge is present in an atom. Very small volume, very small. Okay, बल्कि थॉमसन ने क्या कहा था? Positive charge is present everywhere by plum pudding model, but it is wrong, right? So after the discovery of this Rutherford gold leaf experiment, we said that very small volume of positive charge is present at the center, and due to this a few alpha particles are deflected by an angle of 180 degree. Are you getting? So this is the observation through this gold leaf experiment. Okay, so what are the observation? The first thing is what? A empty space is present and small volume of positive charge is present, and it is situated at the center. Okay, next, conclusion, we can say that the positive charge and most of the mass of the atom was densely concentrated extremely small region. Okay, this concentrated region was called nucleus, because अल्फा पार्टिकल का भी कुछ तो मास होगा और वो स्ट्राइक कर रहे पॉजिटिव चार्ज को. So positive charge and the most of the mass of the atom was densely concentrated in extremely small region. This concentrated region was called nucleus. So उस पॉजिटिव चार्ज जो स्मॉल रीजन में प्रेजेंट है एटम में, उस रीजन को हम क्या कहते हैं? न्यूक्लियस. सो यहाँ पे न्यूक्लियस वर्ड का मेंशन हुआ. द न्यूक्लियस वॉज सराउंडेड बाय द इलेक्ट्रॉन्स moving in a very high speed circular path called orbits. So he said that nucleus is present at the center, and through this nucleus electrons are revolving around the nucleus. Okay, fine, with a high speed in a circular path. This is what circular path, and this circular path is called as a orbit. Fine. Next, electrons and the nucleus are held together by electrostatic force of attraction. So electrons and the positive charge, that is nucleus, are held together by electrostatic force of attraction. Are held together because electron is negative charge and positive charge is a positive charge is a proton. So these two are held together by electrostatic force of attraction. So positive charge is present in the nucleus, so nucleus is positive charge, I am saying like that. Okay, so that is the electrostatic force of attraction is present between this nucleus and the electrons, because as electron is revolving around the nucleus, so there should be a electrostatic force of attraction because both are oppositely charged to each other. Okay, so this is the conclusion of Rutherford Goldleaf experiment. Fine. So we'll try to understand the drawback. Now, what is the drawback? The first one, it could not explain the gravitational force in nature. Means what? See, as he said that nucleus is present at the center, which is positively charged, and the electron is revolving around in a circular path. So there is a gravitational force is present between the sun and the earth. Okay, so same the gravitational force is present in the positive charge and the electron. He could not explain that. Okay, he could not explain that. Second one, it could not explain planetary motion under the influence of the gravity. Under the gravity also, he said that electron is revolving in a circular paths. Those paths are what? Orbits. So this planetary motion he could not explain why it is so. Why not the electron fall into the nucleus? Because this is a positive charge and this is a negative charge, so attraction should be there and electron should fall into the nucleus. But he said that electrons are revolving in a planetary motion. Fine. So he could not explain this also. He could not explain the Maxwell electromagnetic radiation property. So this we will study later. Maxwell's electromagnetic radiation. So you just try to remember, it could not explain the Maxwell's electromagnetic radiation property. And next one, it could not explain the quantum mechanics as a whole. This also will explain the later on. First try to understand. He could not explain the gravitational force in nature. He could not explain the planetary motion under the influence of gravity, and also the electromagnetic radiation. Okay, and quantum mechanics as a whole. So these are the things are called drawbacks of Rutherford's Goldleaf experiment. Now let us try to understand what is electromagnetic radiation and its characteristics. See, light and the other forms of energy propagate without any medium in the space. Okay, हमको मालूम है, in the form of waves. Okay, and those are called as electromagnetic radiation. Waves can produce a charged body moving in a magnetic field or magnet in an electric field. So we know that all things. Example, X-ray, cosmic rays, ordinary light rays. So these are what electromagnetic rays which propagate in a space in the form of waves. So some light or energy, some they travel in the space in the form of waves. Okay. Next one. What are the characteristics of electromagnetic radiation? These waves travels with the velocity of light. So we can say that all electromagnetic radiations travel with the velocity of light. This consists of electric and magnetic field components that oscillate in the direction perpendicular to each other. So they consist of electric and magnetic field component that oscillate in the direction perpendicular to each other and perpendicular to the direction in which the wave is traveling. So there are some points we have to understand. The first one is what? Wavelength. All these things we have learned in a previous class. Okay, now let us try to understand once again. Wavelength, we know that the distance between the two consecutive tufts and crest. So this is your wave. So this distance between the two crests, or this distance between the two tufts, is called wavelength, and it is denoted by the symbol lambda, and it is measured in centimeter or nanometer or angstrom or micron. So wavelength is nothing but the distance between the two consecutive crests. Frequency, it is defined as the number of waves which pass through the point in a 1 second. So it is defined as the number of waves. How many waves are passed through the point in a 1 second? It's called frequency. It's a frequency, and it is denoted by the symbol mu, and it is expressed in terms of a cycle or per second. So it is expressed in terms of cycle or per second, or it is expressed in terms of hertz. So the frequency is inversely proportional to the wavelength. Frequency is inversely proportional to the wavelength. So this formula is also you have to remember. Next one, velocity. So it is defined as the distance covered in a 1 second is called as a velocity, and it is denoted by the symbol c, and it is directly proportional to wavelength. It is directly proportional to the wavelength and the frequency. Now next one is what? Wave number. Next one is what? Wave number. The reciprocal of wavelength is called wave number. It's very simple. The reciprocal of wavelength is called wave number. That is the number of wavelength per centimeter. And last, fifth one, that is the time period. The time taken by the wave for one complete cycle और द वाइब्रेशन इज कॉल्ड टाइम पीरियड. सो सिंपल है, एक कंप्लीट वेव होने के लिए जितना टाइम लगता है उसको हम क्या कहते हैं? टाइम पीरियड. And it is denoted by the symbol t and expressed in terms of a second, and it is expressed in terms of second. So t is equal to, it is inversely proportional to the v. Next one is what? Amplitude. It is defined as the height of the crest or the depth of the tuft of a wave. So height of the crest and the depth of the wave is known as amplitude, and it is denoted by the symbol A, and it determines the intensity of the radiation. So it helps to know the intensity of the radiation, how much intense it is, and it can be measured through what? By knowing the amplitude. Fine. Okay, so we'll stop here, students, and in next class we'll try to understand the emission spectra, line spectra, band spectra, and later on, by knowing the spectrum, once again we will try to understand why Rutherford-Goldilocks experiment has a drawbacks. Okay, we'll try to understand the drawbacks of Rutherford-Goldilocks experiment. Till that, you try to read the books and try to understand the concept. Okay, and if you have any doubt, you can contact me.